Imagine a creature made not of flesh and bone, but of rock. Its skin glimmers like quartz, its movement slow but purposeful, and its very existence defies everything we know about life. Could such an alien being, made not of carbon but of silicon, actually exist? Today, we're diving into one of the most fascinating possibilities in astrobiology: silicon-based life. Let's start with the basics. On Earth, all known life is carbon-based. Why? Because carbon is extraordinary. It's a molecular builder, capable of forming stable, complex chains and rings with itself and other elements. These structures are the foundation of DNA, proteins, carbohydrates, basically everything that makes life as we know it possible. Carbon's ability to form versatile bonds, coupled with the abundance of water on Earth, created the perfect environment for life to emerge. But here's the twist. Silicon, carbon's chemical cousin, shares many of the same properties. Like carbon, silicon can bond with oxygen, hydrogen, and other elements, and it can even form complex molecular structures. So, could silicon support life in the same way carbon does? Scientists aren't ruling it out. Here's the catch. Silicon has limitations. Its bonds are stronger and less flexible, which means it doesn't form long, stable chains with the same ease that carbon does. And while carbon-based molecules function well at a wide range of temperatures, silicon struggles in cooler environments, as its chemical reactions aren't as efficient. However, in hotter, more extreme environments, like on planets with searing temperatures and heavy metal surfaces, silicon might shine, forming structures that can withstand extreme heat and pressure. Now imagine what a silicon-based life form might look like. What if, instead of sweating under the sun, these beings radiated heat through crystalline structures? What if their metabolism wasn't powered by oxygen and sugar, but by absorbing minerals directly from their rocky surroundings? Alien creatures made of silicon might move more slowly, their biological processes dictated by the rigidity of silicon chains. Or perhaps, in their environments, their existence unfolds in ways we can't even comprehend, where time and speed mean something entirely different. Where would we find such life? Silicate-rich exoplanets, rocky worlds full of silicon and other elements, are a prime candidate. Some scientists even speculate that moons like Europa, with its icy surface, or Io, with its volcanic activity, could harbor life forms that have adapted to silicon-based chemistry. Or perhaps massive metal-rich planets orbiting close to hotter stars might serve as incubators for living rock. But here's the question that keeps scientists up at night. Would we even recognize silicon-based life if we saw it? Its biochemistry would be so alien, its appearance so unlike anything on Earth, that we might mistake a sentient being for nothing more than an unusual rock formation. Could we establish a connection with life that doesn't share a molecular blueprint with ours? And what would happen if our carbon-based biochemistry were completely incompatible with theirs? Ultimately, silicon-based life forces us to ask deeper questions. What is life? Is it simply the ability to self-replicate and evolve, or does it encompass phenomena far beyond our current understanding? Could they build towering cities of crystal and obsidian, powered by the heat of their blistering planets?